Welcome to The Explainer. Today, we're diving straight into a massive, fundamental shift happening right beneath our feet. We're talking about the transition from digital tenancy, basically renting space on the internet, to true, verifiable sovereignty in the Web3 era. It's an entirely new way the internet is being architected, and it's absolutely fascinating.
So let's start with a really provocative question. Who actually owns the internet? Or, to put it another way, are we all just captive squirrels living in the cloud empire? Visualizing ourselves as captive tenants is honestly the perfect way to understand the trap of modern internet centralization. Think of the user, you, as a squirrel. In our current digital landscape, you're locked in a cage, being fed nuts by a giant corporate landlord. You definitely don't own the cage, and you for sure don't own the nuts. Your data, your social graph, your identity, it all just belongs to the platform.
But if we map out our journey, you can see exactly how we got here and where we're going. Back in the Web 1 era, the read era, we democratized information through open protocols. Then, Web 2 brought the read-write era. Corporate networks stepped in and democratized publishing. You know, the whole rise of social media. The catch? They centralized all the value and control. Now we're finally stepping into Web 3. This is the read-write-own or verify era, where blockchain networks are actually democratizing ownership.
Here is our quick roadmap for today. We'll start by looking at the era of digital tenancy, then move into read, write, and verify. From there, we'll explore the infrastructure of eddies, check out sovereign AI at the edge, and finally, we'll cross the semiotic bridge.
All right, part 1, the era of digital tenancy.
Think about how the fragile, trust-based promises of centralized platforms completely juxtapose against the absolute mathematical guarantees of blockchains. In Web 2, platforms always start off super friendly to attract users, right? It's a positive-sum game. But once they hit the top of their growth curve, they inevitably enter this extraction phase. They literally have to squeeze value out of users and creators to satisfy shareholders. Their entire motto is basically a subjective corporate promise: don't be evil. Web 3 completely replaces that fragile trust with code. By using decentralized consensus, the rules are baked right into the software. The motto changes to a hard cryptographic guarantee: can't be evil.
Moving right along to part 2, read, write, and verify. So the crucial takeaway here is that we're shifting from simply holding digital assets to actually demanding verified proof of computation, totally bypassing corporate middlemen. You hear the term read, write, own a lot, but a lot of computer scientists argue read, write, verify is actually way more precise. See, in a decentralized network, you really don't want every single computer on Earth recalculating every single transaction just to prove it's valid. That is incredibly inefficient. Instead, the goal is to execute computations off-chain and then use cryptography to easily verify them on-chain.
But to make this verifiable future practically viable, developers need some serious open-source firepower, like A16Z's Jolt ZKVM. What's absolutely wild here is how Jolt bypasses a 30-year technical wall to achieve a massive 6x speed-up. How? By using simple lookup tables instead of super complex math. Traditional zero-knowledge virtual machines get completely bogged down in heavy mathematical arithmetization. Jolt, which literally stands for just one lookup table, fundamentally flips the script. It optimizes sparse matrix processing so efficiently that stuff like zero-knowledge machine learning, which used to be way too computationally expensive, is suddenly entirely practical. It's a real game changer.
Which brings us to part 3, the infrastructure of eddies.
This vividly visceral metaphor completely changes how we view our data. Remember our squirrel from earlier? Well, instead of handing everything over to a centralized landlord and sitting in that cage, you're now operating resiliently out at the edge. The tree is the decentralized infrastructure, but you are the squirrel navigating the branches. You hide your own nuts, your local data and your state, and you just retrieve them when you need them for local computing. You become entirely independent.
And this brilliantly illustrates the concept of leaf node logistics. We are breaking out of the cloud empire to build a whole forest of autonomous, decentralized eddies. Think about fluid dynamics for a second. An eddy is that little localized swirl in a river where the water slows down, depositing nutrients so life can actually flourish. In our new digital topology, your local device, your leaf node, is an eddy. Value and data are retained locally by you, rather than being instantly siphoned off into some massive centralized corporate server farm.
Let's jump into part 4. Sovereign AI at the edge.
Now, if human users can exist in these decentralized eddies, the logical next step is applying this exact same sovereign topology to artificial intelligence. By utilizing A16Z's open-source ELIZA framework,
We're not just trapping AI in data centers anymore. We're equipping them with 4 key components to become autonomous entities that actually manage their own crypto wallets. The framework lets you build an AI with a specific character or personality. The agent runs its memory. But here's where it gets crazy. The providers and actions connect the AI directly to the blockchain, meaning the AI can read a wallet balance, decide to make a trade, and physically execute a token swap, all entirely on its own. Just think about the sheer magnitude of that for a second. These agents transform into deterministic scripters that execute human will with absolute sovereign stewardship, totally independent of tech giants. We are moving way past the era of AI just spitting out text in a browser window. We're talking about AI acting as a secure, verifiable economic agent in the real world. You give it the intent, and it executes the logistics right at the very edge of the network.
And finally, Part 5, the semiotic bridge.
So how do these abstract on-chain digital states actually reach out and trigger physical execution in the real world? Following the ERC 7827 standard, this 4-step semiotic bridge traces a mind-bending path from a digital root securely anchored on a blockchain all the way out to a physical leaf node sitting right on your desk. In the past, connecting blockchains to physical hardware was chaotic, kind of like setting up dominoes where one slight breeze ruins the whole sequence. But this deterministic protocol changes all that. It establishes an on-chain anchor, wraps it in a defined entity, verifies human intent, and then literally sends a specific electrical signal out through a hardware pin, like on a Raspberry Pi, to turn on a light, move a motor, or unlock a door.
I absolutely love this concept because it grounds highly abstract cryptography straight back into the visceral, messy reality of human effort. The protocol doesn't just ask for a digital signature, it literally demands what the sources call a record of sweat. It cryptographically attests that actual metabolic human energy, your physical effort and intent, was spent to execute a mission. You really can't separate the physical reality from the digital protocol anymore. The code is the instruction, but the human provides the horsepower.
Wrapping up this explainer, I want to leave you with a real question to chew on. As we shift from mere tenants to sovereign owners of both code and consequence, how are you going to adapt to this new physical-digital frontier? We're no longer just reading and writing in walled gardens. We're verifying, owning, and literally bridging the gap between digital wealth and physical action right in your living room. The infrastructure is built, the tools are open source, so the only question left is, what will you build at the edge of the network?